Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. So today is a medium problem. The problem says that we get an array and we can choose a set of integers and remove all of their occurrences from the array. And the goal is for us to return the minimum size of the set so that at least half of the integers are removed. So we want to remove the minimum number of unique, like the elements in their unique format, so in a set, such that we remove at least half of the array. So if you take a look at this example here, if we remove all threes and remove 7, for example, we will be left with 5, and this array is of length 10. So if we remove these, then we have 5 remaining, so we removed half, actually 5. We could also do it differently, where we remove the 3 and the 5. We have 3 left. That's more than a half, so we are good there. But we know that we need at least 2 elements to remove 2 elements. In this case, 3 and 7, right? So that's the example there. If we take a look at this example, to remove the half, we don't have a choice. We have to remove 7, and so we remove every occurrence of 7, and so it's just one number. So that's the idea of the problem. Now, how can we solve it? Well, we know it wants the minimum size. So the first thought that can come to mind is, okay, let's just remove the element that occurs the most each time, right? That will surely get us to the half of integers being removed faster, right? Just by definition, greedily. So we find that, okay, 3, for example, here occurs 4 times, 5 occurs 3 times, 2 occurs 2 times, 7 occurs 1 time. So we remove 3 because it's the highest one with 4 occurrences, and then we remove 5 because it has 3 occurrences. Now we are left with 3. That means we removed here 7, which are more than half of the integers, right? We can just remove 3 because then we'd have just 4, right? Remove just 4. But this is generally the idea. Now we just need to code it in an efficient way. So basically we need to, in some way, get the occurrence of each number here. And then once we get the occurrence, we can just get the values of the number of occurrences. So for example, here 4, here we have 3, and then sort that in decreasing order, right? We want the highest element first, and then just count when do we reach half of the integers. So here we reach 7. 7 means that we have removed more than a half, and so we are done. We can just return how many numbers, and in this case it's just 3 and 5, so we return 2. So that's basically the main idea. Now let's just code it up with the here and make sure it works. Okay, cool. So the idea we said is basically just get occurrences and sort in decreasing order, and then remove in occurrence, or remove highest occurrence first, right? Because if we do that, we will get to half of the numbers faster, right? So we need something to calculate occurrences. To do it quickly, I'm going to use Python counter, but you can easily do a map, initialize it to 0 for each element, and then just each time you encounter an element, increment the value of the map on that key, which is the value in the array, by 1, right? So pretty straightforward to do if you want to do it manually. And now what do we want to do? We want to get the occurrences and sort them by decreasing order. So how do we get the occurrences? So this here, for example, let me actually just show you here. This is Python, right? Let's say we have the array that we have in the example, right? So if we do the counter for it, we have 3 occurs 4 times, 5 3 times, 2. And then we want to get the values in sorted order. So we want to get 4, 3, 2, and 1. So what do we need to do? Well, we just want the, let's just first make this assigned to this. What values will give us what we want, which is the values here. Okay, and it's sorted here in decreasing order, but we can force it to be sorted here. So yeah, so if we do occurrence values here, let's just have it sorted, and we want it in decreasing order, so let's just say reverse in Python. Let's call these values. Okay, so now we have them in sorted order, and now we can just go through it, and as soon as we reach the length divided by 2, that means we removed half of the elements and we can return. And each element here, by the way, represents a number that we can remove, right? Okay, so that's the first part. So now let's just take this, add it here, and now we need the length of the array. And we know we want to remove n divided by 2 at least. So let's just call these remaining elements that we need to remove. And now we can just go through the count in each of the values here. And each time we want to remove count. And when do we know that we removed half? Basically when the remainder here is, or remaining here is less than or equal to 0, that means we removed half, right? That's essentially what we are doing here. So we can check if this reaches 0 or even smaller than 0. Then we are done and we can return, but we want to count how many we removed, so let's just call it removed here. And this basically, each element of values represents a number. So for example, 3, it's 4 occurrences. And so here we can just say removed plus 1, because for example, when we do 4, that means we removed 3, so we need to add it. When we do 3, that means we removed 5 occurrences, and so we need to increment removed by 1. So here we return removed, and at the end we can also return removed, although this should not be hit if the problem has a solution. Yeah, so that's pretty much it, right? Just get the occurrence, sort them in decreasing order, and then greedily remove the highest occurrence. So if we run this, submit. Okay, so that passes test cases. Now, in terms of time complexity, we are doing here of n time, right, with this loop here, with these values where we can have each element occurring once, right? And then in terms of space, so this is O of n time. In terms of space, we are using this collections counter, which is basically similar to a map, and it has the size of the array. Same thing with these values here, so O of n space as well. Yeah, so that's pretty much it for this problem. Yeah, please like and subscribe, and see you on the next one. Bye.